And what do you expect of 2022? What will be your next breakthrough?
I recently got a VD proposal funded.
And also making the model much closer to nature.
Yeah, exactly. So it's going to be more complex, but also more realistic. And here we're going to look at how bioturbators, so you could think of fish, but also small microinvertebrates that bring oxygen in the sediment, how they may mitigate methane emissions.
Interaction and collaboration between students is not only important during the COVID times, but also in the normal face-to-face situation. This is the collaborative learning room where a lot of the team-based learning activities take place. And this is Steve Hansen. He's a lecturer for environmental science, and he is already working with team-based learning for quite some time.
I hope that it would be implemented in part of the curriculum so that students get more familiar with this structure and that the benefits of the structure are further enhanced basically by having it in different courses.
The main plan now is to develop these cooperations between us social scientists. There's a historian of science involved, and there's computer and data scientists. We want to try and track errors and see how error correction processes work. So we want to try and investigate some of those new forms of communication and see if we can facilitate error correction, make science nicer.
Well, we will go on. We have a number of biomarkers sort of in the pipeline towards identification for a number of different of these metabolic diseases. So we do this in collaboration with the Translational Metabolic Laboratory here at Radboud UMC. So when we identify a molecule, we do that sort of reference-free, and we do an identification based on a predicted infrared spectrum. And if we have a very good prediction, then we actually go to Floris Rutjes and ask them, can you synthesize exactly this molecule? And when we have that physical standard in hand, then we can do a definite identification. In 2020, we have many visitors, as I said, from the United States, from all over the world, basically. And we hope to go back to that situation as soon as we can.
We really want to build our group further, so we're really growing, which is nice. And we are also working with students who are doing their bachelor internships here or their master internships. It would be great if we could really establish a community of people who are interested in science education research.
I'm actually going to broaden my research interest into energy conversion research. For example, by converting nitrogen gas from air to ammonia fertilizers. We are going to make ammonia fertilizer using renewable resources, sustainable resources, for example, air, water, renewable energies such as solar or wind energy.
I expect lots of fun science, starting with this new microscope, which is the only one in Nijmegen and in the Netherlands and in Western Europe.
2022, we will be focusing on a project that's related to triple-negative breast cancer. We're going to collect data in a very specific way, and we're going to develop a model that's able to simulate the behavior of triple-negative breast cancer cells and hopefully predict some therapeutic targets.
So we try to understand what happens if you consider a space, but you only can measure it, I mean, think about this in physical terms, up to a certain resolution, some epsilon, as we like to call them in mathematics. In mathematical terms, something of last year, I mean, it can have an effect in decades from now. So I really hope to develop this more in detail. How can we actually describe these geometries using this formalism, because it's really fresh.
Collaborations ongoing and starting that I'm really looking forward to, often on that theme of computers taking decisions with far-reaching or possibly far-reaching effects for people. And we are busy on several projects. On one, for instance, the discrimination-related risks when AI is used in the insurance sector. Super exciting too, really difficult questions.
In 2020, 2022, what we hope to be able to achieve is to set up this cross-disciplinary technique. And hopefully, in a couple of years after that, we'll start having, some clues about what are the molecular changes that lead to neural activity changes that fundamentally then lead to the emergence of memory.